right? So PQ is a common tangent. So my first thought is tan chord, right? Now here we can actually use tan chord 4 times because we have a big circle and PQ, the fact that they're saying that PQ is a common tangent, that means that it's a tangent to the big circle and to the small circle. All right, so I'm going to use different colors here. A1, do we agree that if we're looking at the big circle, right, A1 is an angle between the tangent and chord AD. Yep. And then AD subtends angle E. So A1 is going to be equal to E. So guys, again, I'm doing that before I've even read the question. Okay, I'm seeing that it's a tangent, so I'm filling in what that tells me. But then A1, because PQ is also a tangent to the small circle, let's just cover up the big circle or part of it. A1 is the angle between the tangent and chord AB as well. And then AB is subtending C1. So those two angles I can also say are equal because of tan chord. Then on the other side of these triangles, I have A3, which is an angle between the tangent and in the big circle chord AE. And then AE subtends angle D at the circumference of the big circle. So A3 is going to be equal to D. And then if I'm looking at the small circle, A3 is an angle between the tangent and chord AC. And then AC subtends B1. So guys, there we already have that in our triangles here, C1 is equal to E and B1 is equal to D, right? So I can already kind of see what I'm going to have to do here. I'm going to have to work with the small triangle ABC and then the big triangle ADE. I already have those two angles equal, those two angles equal, and then even the third angle here is a common angle. All right, or you could say angle, sum, and triangle. But what if we couldn't see that? What if this was a more complicated diagram and we had to figure out which triangles to work with? Okay, I'm going to look at the one fraction, so as in within that fraction, right? That is AC and AE. What letters are there? A, C, and E. A, C, E. Is that a triangle? No. No. All right? And if I look at this, B, C, D, E, I mean, that's even too many letters, right? B, C, D, E, you can never have a triangle with 4 points, 4 vertices. Okay, so that's not going to work. So guys, within the one side of the equation and then the other side of the equation, I'm not getting 2 triangles. So now we're going to look across. So what I then usually do is I look at the 2 numerators. So I look at those ones. Let me zoom in a bit. So AC and BC, what letters are there? ABC. Is that a triangle? Yes. Okay, so I have, I'm just going to write it there at the top. I have ABC, which is a triangle. So if I use triangle ABC, I'm going to get AC and BC for my 2 fractions, which is perfect. Then I'm going to look at the bottoms, the denominators. The 3 letters that I have there are ADE. Right? And is that a triangle? ADE? Yes, that is the big triangle. So I'm going to work with that triangle because if I work with that triangle, I'm going to get AE and DE from it. Because AE and DE are both sides in that triangle. All right. Like I said in this picture, again, it's quite obvious which 2 triangles you need to work with, but I promise it's not always going to be the case. All right. So you need a method that you can use to find the triangles. Because sometimes there are like 6 triangles. And what are you going to do? Are you going to try and prove all of them similar until you find one that works? No, that's going to take way too long. All right. So look within the one fraction. Does that give you a triangle? In the other fraction, does that give you a triangle? If that doesn't work, then you look across the tops and then across the bottoms. All right. And then you identify your triangles from there. Okay. So now we're going to write down in triangle ABC and triangle ADE. Now guys, we already have enough information to prove that these two triangles are similar. So I'm going to start. Can we start by saying A2 is common?
Yes.
Okay, A2 is common. We don't need a reason for that. And now, number 2, guys, remember that we wrote ABC first, so we need to write the information of ABC first. So we have B1 is equal to D, but why is that? Because B1 and D are both equal to A3. Okay, so let's write it like this. Let's say B1 is equal to A3, and D is equal to A3. Now I'm writing it like this because I have the same reason for both of these statements. It's tan chord theorem for both of them. If you had two different reasons, then you would have to write the one statement with the reason, then the other statement with the reason, like we did in the previous question that we marked. Okay, but because it's one reason for both of these, you can write a little bit less, and you can write both statements with an and in between, and then write the reason only once. Okay, you are allowed to do that. Therefore, B1 is equal to D. They're both equal to the same angle, A3, so they have to be equal to each other. And then for the third pair of angles, now guys, we can do the same thing, right? Because we proved that they were equal also using tan chord theorem. But what can we also always use for the third pair of angles? Angle, sum, and triangle. And that's actually going to be less writing. Okay, I'm thinking about time in an exam. We can write C1 is equal to A1 and E is equal to A1, tan chord theorem. Therefore, they're equal to each other. But we can also actually just say C1 is equal to E, angle, sum, and triangle. All right, that's much quicker. That will take up much less time. So C1 is equal to E, angle, sum, in triangle. So guys, even if there is another way of proving your third pair of angles equal, you can always write angle, sum, and triangle. That will never be wrong. Therefore, triangle ABC is similar to triangle. And now note, guys, again, I put my letters of the first triangle in the order that I wrote them down, right? So that I can use that same order for the next one. That's the easiest way of doing it. So ABC is going to be ADE. Right, triangle ADE. In this case, it worked out that it was in alphabetical order for both of them, but it won't always be the case. All right, so you match them up in your 1, 2, 3 lines that you proved. And now we need to get to the fraction that they asked us to prove. Now guys, let's look at the first half. The first half of that fraction is AC over AE. Can I get that from my similarity statement? AC over AE, right? So now I'm just going to say, therefore, AC over AE is equal to, what was the second fraction? BC over DE. Now that was, let's look at BC is over there, my second and third letters, and DE as well. So I can just write that straight away, BC over DE. You can write the third fraction if you want to, but we don't need it, guys, because we've proven now what they asked us to prove. All right, your reason though, please, important, similar triangles.